Hey, Salam Rashid, how are you doing? This is with regards to what we were or discussing on phone. I'll just take you the brief. Just wait till the camera focuses. Okay, on the brief part, because I'm not very sure of what you would be needing per se. So we're talking about the impairment scenarios. I'll be talking about the design for a temporary refuge with AND gates and OR gates and all that, which all we will have to consider. And with the companies that can, the specialist company that can do your services, and the EPC that can give you the license for it. License, as in the how do you say, as you hand it over to you, you have a guarantee for working and all. So we will take it one by one. Rashid, this is video number 2. We will talk about the impairment scenarios. So, the impairment scenarios for temporary refuge design, which we had considered, DNV Spouge or CMPT offshore, as well as Lord Mackellan's report, I can send it to you, talks about various things that we will have to look ahead for doing our failure case estimations. That can be using linear models, which are Farsafeti, Fred, and models likewise, which are basics of our TNO Yellow Book models. Vis-a-vis that CFD, where the wake analysis and all, and for CFD things like FLAX, CFX, FDS, or any other can be helpful. So impairment scenarios, should an OR gate consider about the events which has immediate ignition, delayed ignition, no ignition, and additionally flare flame out, stacks and furnace emissions, and other fugitive emissions. Immediate ignition shall, as we know, entail flame radiation, smoke entrainment, out of which flame radiation is not that much of a risk integral, but yes, smoke it is. Delayed ignition, we need to look into the overpressure, which is this, not only the siren overpressure but also the drag and the vacuum. Snapples, which are in case of an explosion, if there are things hitting the windows and doors and all that, or the building structure as such for the school. And for no ignition, which will be the toxic flammable gas ingress, toxic gas ingress, not only limited to H2S, maybe ammonia and also CO2. Flare flame out case to be considered. Furnace and stack emissions because of heater failure, furnace failure, runaway reactions, other any fugitive emissions. From HAZOBs, we'll come to know from the other. Rashid, this is video number 3. Talks about temporary refuge design, Chemical Industries Association, BPGP 4802, DNVGL, NORSOC. Similar standards talk about the design specifically as well as Shell DEP. So for the schools, normally it takes 90 minutes temporary refuge, which will be account 90 minutes or greater with respect to the assessments that we have identified from the worst case scenario. Room designs, floor space talks from 1.5 sitting, 1.5 meter square per person sitting to 0.5 meter square standing. So design shall entail an OR gate for thermal radiation, toxic gas ingress, blast over pressure, smoke or CO, carbon monoxide ingress, humidity, temperature, hospitable conditions. So, thermal radiation, blah blah blah, we know the H rating, J rating, and all that, but I don't think thermal radiation will be a major factor. Toxic gas, yes. Toxic gas, again an OR gate. So, for toxic gas ingress, the design should entail HVAC, like you rightly stated yesterday, zoning of the HVAC dampers, and the room sealing capability. Sealing capability of the room. For HVAC, it could be via detectors or via H2S scrubbers if they are proven in design, proven in use and efficiency. Zoning of the H2S dampers so that the dampers close and zone such that the room so designed within the school is capable to act as a temporary refuge or muster or however you want to call that. Room sealing capability, and this is what you were also talking about. ASHRAE has a permitted leakage rate. So from the damper, whatever room is that, we need to do a positive pressure, a built-up assessment as per the ASHRAE standard to see that this particular room is capable leak-proof. And this is actually one of the HSE critical activities for the identified HSE critical room or HSE critical element. So from toxic, it is the blast overpressure, like the blast overpressure, fairly straightforward. Smoke and CO2 ingress, similar for the HVAC as we stated, but the detectors and the scrubbers need to be for the entrainment gas. Humidity and temperature. So that is again an OR gate. Humidity and temperature, and or that is plus a breathing air assessment. So for humidity and temperature, it can be via a split AC, but the junction box should be zone 2 and the unit should be in the safe area, because the split AC unit is usually outside. It should be either in a safe area or that also should be ITEX rated. For breathing air, because it has humidity, temperature, and also breathing air assessment, how much is the oxygen that is there in the room. So for that, you can either put pressurized breathing air tanks which will refill and maintain the oxygen, or else we will have to do a breathing air assessment considering the number of students, their inhalation and exhalation rate, and ensure that the drop of oxygen does not go less than 20%. Sorry, how much? 19% or something. There is an assessment likewise, but this is what we all need to go for. Then hospitable conditions, that is the room should have access to toilets and food and power and telephones, and this all this particular access should be under that sealed room.